All right, let's dive in. Today, we're talking about one of the coolest and, honestly, simplest tricks in all of algebra, the vertical shift. We're going to learn how to take an entire graph and just slide it up and down the page. It's awesome.
But first, just think about this for a second. A line goes on forever, right? It's infinite. So how on earth could you move that entire thing up or down with just one tiny little tweak in its formula? It sounds like it should be complicated, but you're about to see just how easy it is. The secret is to think about it like this. The whole graph takes an elevator ride. That's the big idea for today. Our job is just to learn how to be the elevator operator and tell the graph which floor to go to. So, let's get official for a moment. This elevator ride is called a vertical shift. Now, the most important part of this definition is that last bit, without changing its angle or shape. This is key. The elevator only goes straight up or straight down. It doesn't tilt, it doesn't get stretched. The line keeps its exact same steepness, it's just in a new spot.
Okay, so how do we actually press the buttons on this mathematical elevator? Well, it all comes down to one super simple rule. And when I say simple, I really mean it. This is where the magic is.
Here it is. The whole control panel is just one little letter, k. When you see a function that looks like this, g of x equals f of x plus k, think of it as a recipe. It's just telling you that your new graph, g of x, is the exact same as your original graph, f of x, but with some number k added or subtracted at the very end. And that k is our up or down command.
And the rules for our command could not be more straightforward. If k is positive, the elevator goes up. So x plus 3 takes your graph and moves it up 3 units. If k is negative, the elevator goes down. X minus 5 moves it down 5 units. That's it. Positive is up, negative is down. That's the whole rule.
And this is absolutely crucial to remember. Because we're only going up or down, the slope never ever changes. The new line will always be perfectly parallel to the old one. It's just as steep as it was before, just starting from a different height.
All right, theory is one thing, but seeing this in action is where it really starts to click. So let's run through a few examples and put these shifts into practice.
First up, let's describe what happened to get from f of x equals 2x to g of x equals 2x minus 4. So step 1, we compare them. See how the 2x part is exactly the same? That tells us the slope hasn't changed. The only new piece is that minus 4 at the end. Well, that's our k. Since k is negative 4, we know the graph moved down. So the full description? It's a vertical shift down 4 units. That's all there is to it.
Okay, let's flip the script. Now you're in the driver's seat. We're going to start with the most basic line there is, f of x equals x. Your mission is to write the new equation that shifts this line up 2 units. What do you think you need to do?
If you were thinking, just add 2, you hit the nail on the head. To move the graph up by 2, our k value is just a positive 2. So we take our original function x, and we just tack that plus 2 right onto the end. The new function is g of x equals x plus 2. See? It's that direct.
All right, time to level up just a little bit. What happens if our starting function already has a number at the end? Let's take f of x equals 3x plus 1 and shift it down 5 units. The logic is exactly the same. There's just one tiny extra step.
So the rule says to apply the shift to the entire function. We take that whole thing, the 3x plus 1, and since we're going down 5, we subtract 5 from that whole expression.
And now it's just a little bit of cleanup. We have a positive 1, and we're taking away 5. We just combine those numbers. 1 minus 5 gets us to negative 4. And there it is, our final answer, g of x equals 3x minus 4. And it makes perfect sense, right? The graph started at a height of positive 1, we rode the elevator down 5 floors, and we ended up at a height of negative 4. Now this concept is super straightforward, but there are a couple of classic traps that people sometimes fall into. So let's quickly go over them so you can avoid them. Okay, trap number 1 is putting the number in the wrong place. For the up and down vertical shifts we're doing, the k always goes on the outside of the function, added at the very end. If you accidentally stick it inside with the x, like f of x plus k, you've actually told the graph to do a totally different move, a horizontal, side-to-side shift, so always keep that k on the outside.
And the second big trap? Forgetting about the number that was already there. Like in our last example, if you start with 2x plus 7, and you need to go down 2, you don't just replace the 7 with a 2. No, you start at floor 7 and go down 2 floors, which lands you at 5. Your new function is 2x plus 5. Remember, always combine, never replace.
Okay, so we can add a number to move a line up or down. Why is this such a big deal? Well, because this idea is so much bigger than just straight lines. Let's talk about why this simple shift really matters.
First off, you see this all the time in the real world. Imagine a company where everyone gets a flat $5,000 raise. The relationship between, say, years of experience and salary, the slope of that line, it doesn't change. The entire salary graph for the whole company just shifts straight up by 5,000. That's a vertical shift. But here's the real payoff. This whole plus K means up, minus K means down idea, it is a universal rule in math. When you get to parabolas, those U-shapes, adding a K moves them up and down. When you get to absolute value graphs, the V-shapes, same thing. Even those wavy sine and cosine graphs in trigonometry follow the exact same rule. This is a concept that will keep coming back again and again.
So by really getting a handle on this one simple idea, you're not just learning a skill for one chapter. You're basically getting a master key that will unlock tons of future topics in math and make them feel way easier when you get there.
So we've nailed it. Adding and subtracting gives our graph an elevator ride, which leaves us with a great final question to chew on. If adding and subtracting slides the graph, what kind of transformation do you think multiplying is going to do? Think about that one. We'll see you next time.